Bismillahirrahmanirrahim. So you remember that in the last class we have discussed about electric field. What was electric field? Okay, if you have any charge, okay, let us say you have a positively charged body, it will create a certain area around it within which it can apply force on other charged object, right? On another charge, it will be able to apply force. Outside this area, it will not be apply any kind of force on any charge, okay? So now within this electric field, there are several points, right? Now each point has electric intensity. Now what do we mean by electric intensity? The force applied on a unit positive charge. See, electric intensity, it is basically a force. Okay, it is basically a force. Okay, remember. So electric intensity is the force applied on unit positive charge. These are the main points of the definition of electric intensity. The force applied on unit. Unit means 1 coulomb. Positive means plus, plus 1 coulomb. Right. Charge placed at a point in an electric field is called electric intensity of that point. Now we know that this charged object has an electric field over here. Now at any point, if I put plus 1 coulomb charge, this is unit positive charge, right or wrong? So definitely as this point, we have placed it at a point within the electric field. So this charge will be able to exert a force on this one, right? What is the amount of force? That force is called the electric intensity of that point. Remember, you have to mention that it is electric intensity of that point. Why it is very important to mention the point? Because if you change the point, the force will change. Now let us say I have brought this one closer. I have placed plus 1 coulomb charge nearer. So what do you think? The force will increase or decrease? As I have brought closer, the distance is decreased, so the force will
Increase.
increase. From Coulomb's law, we know the as the distance decreases, the force increases, right? So that is why it is important. So you can see that as the force is different at different point, so the electric intensity will also be different because the electric intensity is nothing but the force. So force on unit positive charge, right? So we have unit positive charge. I place it at different point. I get different force. So electric intensity also different. That is why electric intensity is different for separate points. Okay, different point, different electric intensity. That is why it is important to mention that I'm talking about electric intensity of that point where the unit positive charge has been placed. If you shift it or displace it, the electric intensity will change. As the point is different now, you have placed the unit positive charge at different point, so you will get different electric intensity because the force will change as the point where we place it changes. Okay, so let me go through the definition once again. The force applied on a unit positive charge placed at a point in an electric field. In an electric field, at a point we will place unit positive charge, some force will be applied on it. That force is called electric intensity of that point where you have placed it, okay? Of that point, of that electric field. What is the symbol? The symbol is E. Okay, electric intensity is expressed with E. I did not write the unit because I want to know the unit from you. Okay, you will look at the equation that we are going to develop, and from there you will tell me what should be the unit. Okay. Okay. So explanation is like this: if force F is the force applied on Q amount of charge, then the electric intensity should be F by Q. Now, how did we get this? Let me explain it in this way. We have Q amount of charge. On Q amount of charge, the force that is applied is F. Now, on 1 coulomb charge, we know that it has to be unit. On Q, if the force is F, then on 1 coulomb, how much it will be? F divided by Q. So this is the force applied on unit charge. So this should be intensity, right? So that is why E is equal to F by Q. Now from this,
Sir, at
follow?
unit Newton coulomb, Newton per coulomb maybe.
Very good. Yes, Newton per coulomb, because force, this has a unit of Newton and charge has a unit of coulomb. So Newton by coulomb or Newton per coulomb, right? And C inverse 1. Very good. So this is the unit of electric intensity. Anybody has any doubt? If we are done with the concept of electric intensity, then we are going to solve a mathematical problem related to it. Can I move to the mathematical problem?
Yes, sir.
Yes, sir.
Let's see. I will write the question on the board and then I will solve it, inshallah. Okay, so we have the problem on the board. If a body of charge 5 coulomb, so we have the value of Q. So we will write given Q is equal to 5 coulomb is placed at a point in an electric field, then it gains a force of 200 Newton. Okay, F is 200 Newton. Find the magnitude of electric intensity at that point. E is equal to what? So we know E is equal to F by Q. So E will be equal to, put the value of F, that is 200, divided by Q, that is 5 Newton by Coulomb. So E is equal to 5 to 4, 40 Newton per Coulomb. Okay, that is our answer. Very easy problem, very easy solution. Do you have any doubt?
No, sir.
Okay. Now, sometimes it might happen that the force is not given, but the electric intensity is given. Like, I can change the question like this. The force is not given, okay? Let us say the electric intensity is given. Let us just ignore this part. Let us say in the given part, the force is unknown, but the intensity is known. So this situation might also, you can see in the exam. So how can you solve? What you have to do is, as you have to find out F, develop an expression for F, cross multiply. Then it will be F equal to QE. Okay, F equal to QE. So Q is given as 5 coulomb into, okay, then E is given as 40. Okay, now you can see that you might be thinking about the unit, right? It should be Newton, but how it will come Newton? See, Coulomb has a unit of, a Q, charge has a unit of Coulomb, right? Into 40, this is Newton per Coulomb. Newton per Coulomb means Newton by Coulomb. So it is clear, very clear, right? C and C will get cancelled and there will be only 200 Newton. Understood? So sometimes out of these three, two might be given. You have to find the third quantity. Is it clear?
Yes.
The next topic that we have is electric lines of force. Okay. So from this topic, the paragraphs are written in the book. Kindly go through it, but I will discuss with you the main points. Okay, what you need to know about electric lines of force. Number 1 point, okay, this is a positive charge. Electric lines of force will be coming out of it. Now, how it will come out? It will come out perpendicularly. Now, what do I mean by perpendicular? See, from the center, if you draw radius outwards, it will be perpendicular, okay? It will be perpendicular. from the center, okay? Along the radius it will come out. Do you understand? I have drawn very few, but there will be actually so much more. They all will be perpendicular to the surface, okay? To the surface, they all will be perpendicular, 90 degree. And this is number 1 point, and they will come out uniformly, okay? Uniformly means it will not happen that on the top side there will be more electric line of force and on the bottom side there will be less amount of electric line of force, or right side there will be more, left side there will be less. No, uniformly, okay? That is how I have tried to draw it. I don't know how much uniformly it looks, okay? But this is the type, okay? Then number 2 point is electric lines of force, come out of the positive charges and enter into the negative charges. Let us say we have a negative charge here. So what will happen? This line will be attracted towards that, right? Positive is attracted by the negative. So the lines of force will go and enter over here, okay? All the lines of forces will try to enter. So it will go like that. Understood? So remember this important point that the electric lines of force comes out of the positive charges and enters into the negative charges. Okay? And this is the case when there is opposite charges. One is positive, one is negative. But what will be the case? How will the electric lines of force look like when both of them are of same nature? Okay? Let us say both of them are positive. The figure is given in your book. I will try to, show it how it looks like. Okay, they will be like this. See, they wanted to meet, but they saw that they are of same nature, so they repelled each other and going back. Okay, so the lines of force will be something like this. See, they are kind of repelling each other, right? The figure is given in the book, so you can see it from there. So this will be the case. Now, as they are repelling each other, okay, in between there will be a place, there will be a point where no force will be felt. Okay, that point is called neutral force. That point is called this X, or the cross point is called neutral force. At this point, through this point, no lines of force pass. As they are repelling each other, they will move away from each other. And at this point, you will feel that no force is there. Okay. Now, this is the case when two charges are equal. This is plus 5 coulomb, this is plus 5 coulomb. So, equally repelling each other. But what if one force is greater and another force is a little bit smaller? Then how the charge lines will look like? This one is greater and this one is a little bit smaller. Okay, this one is greater. So, the lines of force now will look like this. Now the neutral point will not be actually right at the middle. Okay, it will be a little bit closer to that. Okay, I am actually not very good at drawing, that is why it might be difficult for you to understand. But can you see that previously it was equal from both the sides, the repulsion, but now this one has greater amount of charge, so that is why it is applying more amount of force on that one. So this electric line will be more closer to that, and this one will be repelled with a strong amount of force. Okay, I don't think actually my figures are that much clear, but you can go through the figure of the book, and if you listen to what I say, if you replay the video and listen to what I say, then inshallah it will be clear to you. Okay, then our next topic is electric potential. Okay, I think it's better if we start this topic in the next class, inshallah. Okay, so electric potential, from this we will start in the next class. So before we end today's class, anybody wants to ask any question?
No, sir.
Easy topics, right? And easy mathematical problems. Okay, and let's stay updated. Okay. Okay, then see you in the next class, inshallah. Assalamu alaikum warahmatullahi wabarakatuh.